Welcome to our video lesson on the surface area of cylinders. Now the surface area of a cylinder is just like the surface area of other 3D shapes we've been looking at. The surface area of a cylinder is the sum of the areas of its faces. So if we think of all these cylinders here, think about the different faces or the net of the cylinder. And if we find the area of each face and add them together, that will give us the area of the whole surface of the cylinder. If we look at this cylinder right here, it tells us it has the height of 18 centimeters and the diameter of 10 centimeters. Let's think about what its net would look like. So this top circle here would form this circle here. The next part is actually this part here. If we unroll the side of the cylinder, we unroll it and are given this lovely rectangle. And the bottom part is another circle, just like the circle that was on the top. So we would have two circles and a rectangle. So every single cylinder has a net of two cylinders and a rectangle. Now let's use this net here, it's a little bit smaller, to figure out what these dimensions mean. The dimensions we have here, the d equals 10 and h equals 18, what that mean on our net. So this means that the diameter of our circle up here is 10 centimeters. So that means the diameter of each of my circles on here would also be 10 centimeters, because if you think of the top and the bottom of the cylinder, they are going to be exactly the same circles. This would have a diameter of 10 centimeters, and the same with this circle down here, 10 centimeters. All right, now this rectangle, it says here that the height of my cylinder is 18 centimeters, which means that on my rectangle here, the height of my rectangle will be 18 centimeters. The part that we're not sure of is this side length here. It's the width of the rectangle. Well, there's something very, very special about the relationship between this circle and the side length of this rectangle. If we take the circle and roll it along the edge, just like I just did, of this rectangle, your circle will go one full length around, which means that the relationship between this edge and the distance around the outside of our circle are equal. Another way to say that is that the width of our rectangle is equal to the circumference of our circle. Let's take some time and do the example together to help it make more sense. I'm going to redraw this over here so you can see it. Okay, let's start with the area of our circles, because that's a very nice place to start. Well, first I have to write what our whole surface area would be. So our surface area would be equal to 2 times the surface area of our circles plus the surface area of our rectangle. So in order to solve this equation, we need to figure out the surface area of our circle. Let's do that first. The surface area of our circle. Well, we know the area of a circle is equal to pi r squared. Now for pi, we're going to use 3.14 times r squared. Well, we have the diameter of our circle, and that means that our radius has to be half of our diameter, or the distance from the center to the outside, and that would be 5 centimeters, because that's half of 10. So I would have 3.14 times 5 squared. I have to do my exponent first, so 5 squared is 25. And then I have 3.14 times 25, which would give me 78.5. Now we have to think about our units. It's measured in centimeters. And because this is the area, it's going to be centimeters squared. Okay, now we've got the area of our two circles. They are exactly the same circle because they have the same diameter. And so we only need to do one calculation for that, and that's why it's 2 times the surface area of the circle. All right, the next one is we're going to find the area of this rectangle here. In order to do that, the area of a rectangle is equal to length times the width. Well, I know the length is 18, but I don't know this width. And that's what we're going to have to do now, is we're going to have to figure out the width of our rectangle. All right, I told you the special relationship that the distance around the outside of our circle is equal to this side length here. Well, the distance around the outside is called the circumference. And to find the circumference of the circle, there are two different formulas we can use. In this situation, we are given the diameter, so I'm going to use C is equal to pi times D. Well, for pi, I'm going to use 3.14 times our diameter, or D, times 10. 3.14 times 10. Whenever you're multiplying a decimal by 10, you can just move the decimal place over one spot. So this means 31.4 centimeters. Now, why is this in centimeters and not centimeters squared? We are not going to write centimeters squared, because this isn't the area across the inside of the circle, it's just the distance around the outside, it's a length. So it's not squared because it's not an area. So that means that this side here is 31.4 centimeters. So my rectangle is equal, the area of my rectangles is the length times the width, which is 18 times 31.4. And when I do that, 18 times 31.4, that gives me 565.2. And again, it's centimeters squared because I'm measuring the area in the inside of this rectangle. It's this whole space here. Well, now that I've got my area, sorry, I should have written area here. It's not the surface area. It's not 3D shape. So let's just correct this quickly. So my surface area of my cylinder is equal to 2 times the area of my circle. So that's this one here. And plus the area of my rectangle. This one down here. So now I'm going to plug them back into my formula up here. So now I'll have 2 times the area of the circle, which was 78.5, plus my one rectangle, which is 565.2. First, I multiply my 2 times my 78.5, and that's going to give me 157 plus 565.2, and when I add those together, I get a total of 722.2 centimeters squared. So that's the surface area of my cylinder here. Let's do another example. If a can of Campbell's chicken soup is 10 centimeters tall and the can has a radius of 3 centimeters, how much metal is needed to make the can? All right, I'm going to start by circling some important information here. The question I'm trying to figure out is how much metal is needed to make the can. So this is really asking us for the surface area of this can. And I know that it is 10 centimeters tall, so let's add that. We know it's 10 centimeters tall, and that the radius, the distance from the center of this can to the outside circle, is 3 centimeters. All right, now if we think of the net of this shape, I'm going to sketch it really quickly. We have, again, a rectangle with 2 circles. My circles have a diameter, sorry, I have a radius, not a diameter, radius of 3, and my rectangle has a height of 10. All right, so again, I'm going to start with my formula for the surface area. My surface area is going to be equal to 2 times the area of our circle plus the area of our rectangle. first, let's find the area of our circles. So the area of our circle is equal to pi r squared. So for pi, I'm going to use 3.14. And what's my radius in this case? My radius is 3 centimeters times 3 squared. So first I'll do 3.14 times 3 squared. 3 squared is 9. So then I have 3.14 times 9. And that's 28.26. And is it going to be centimeters or centimeters squared? Hopefully you said centimeters squared because we're looking at the whole area of the circle, not just the distance around the outside. So now I have my area of my circle. So I can do 2 times the area of my circle, which I found is 28.26. Now I need to find the area of my rectangle. Let's use a different color for that. The area of the rectangle is equal to the length times the width. Well, I know the length is 10 centimeters, but I don't have our width for our rectangle yet. So remember, the width here, let me use a different color. The width here is equal to the distance around the outside of my circle, or the circumference of my circle. So to find the circumference of my circle, I'll do it over here. I have 2 formulas. I can either use 2 pi r, or I can use pi d like we did in the last one. So in this case, we're given r, or the radius. So I'm going to use 2 pi r. If you wanted to do pi d, you absolutely can. Just multiply your radius by 2 to get your diameter. So c is equal to 2 times 3.14 times r, so times 3. Well, I know that 2 times 3 is 6, and I can do that first. So I have 6 times 3.14, which is going to give me 18.84 centimeters. This is not centimeters squared, it's just centimeters because it's the distance around the outside. So now I know the width of my rectangle is 18.84 centimeters. All right, I'm going to multiply those together, and because I'm multiplying by 10, again, I can actually just move my decimal over one spot, and I'll get 188.4 centimeters squared, because it's the area. Or if you think about it, this is centimeters times centimeters, and we know from using exponents that centimeters times centimeters would give us centimeters squared. So let's go back up to my formula. So now I can say plus the area of my rectangle, which is 188.4. So my first step is to multiply 2 times 28.26 is equal to 56.52 plus 188.4 will give me 244.92 centimeters squared. And that is my final answer. Now let's answer the question in words. So it said how much metal is needed to make the can. 244.92 centimeters squared of metal is needed for the can. All right. Let's make a quick summary of what we've learned in the video. The first thing we've learned is that the surface area of a cylinder is the sum of the areas of its faces. So it'll be the sum of the circles and the rectangle. Hopefully you understand that. The net of a cylinder is made up of 1 rectangle and 2 circles. So that's like this shape down here. We have 1 rectangle and 2 circles. Hopefully you're okay with that. The next one, to find one of the dimensions of the rectangle, this one across here, I've been calling it the width. Calculate the circumference of the circle. So the distance across here, the width of our rectangle is equal to the distance around the outside of our circle, which is pretty special and unique. So those are the key ideas from this video on finding the surface area of cylinders. Feel free to rewind any part of it and rewatch it as you need to. That's all for now, and I'll talk to you later.